going to talk about Ohm's law with series circuits. Voltage, current, and resistance, they all work together. So if you can understand how they interrelate with each other, you got a good grasp on what the foundations of electronics is. Voltage, we use a capital V. Current, capital I. This is for volts. This is for amperes. And we use capital I, but for amps. Resistance, we use a Greek letter omega, and it is in ohms. If you look at voltage, and you look at a tank on top of a hill with a pipe going down the hill to another tank. And we have the tank full of water. The potential is going to have the water flow down into the lower tank. This is what voltage is. You can look at. The movement of water through the pipe would be your current. That's your electrons that are moving. If you don't have electrons moving, you don't have current. If I take the pipe, reduce it down, I'm adding resistance to the water flow that goes through. So there's the three base categories, or concepts of it. If we apply it to a circuit, add a couple resistors, call this R1, this R2, and this one here, we'll call it 100 ohms. This one here, 220 ohms. And we'll apply 10 volts DC to it. Now electrons are going to move negative to positive. If you go with the conventional current theory, it's normally positive to negative. The electron hole theory, it goes from negative to positive. So Ohm's law, or with series resistors, to calculate total resistance, all you do is add the resistors. Does not matter how many resistors are in series. Series says the electrons have only one path to move. They don't have anywhere else to go. They just got to follow the one conductor. So we have 100 and 220. So for total resistance, we would have 100 ohms plus 220 ohms, and that would give us our 320 ohms. So now we have total resistance of our circuit. We have a voltage. So if I want to calculate my current, my total current for the circuit, I'm looking at current equals voltage divided by resistance. I have 10 volts, 320 ohms, and that comes out to about 30 milliamps, or 0.030 amps. So now I have total current, I have total resistance, and a total voltage. If you measure current anywhere on this circuit, it's going to measure the same in a series circuit. So if I put a meter, an ammeter here, or here, or here, it's going to measure the 30 milliamps. So from that, Kirchhoff's voltage law says that my voltage source equals the voltage drops right here on out. All these voltage drops have to equal my source. So to calculate a voltage drop of R1, I would have my voltage of R1. I know my total my resistor value, 100 ohms, and now I know my current. And so to do the calculation, you come up with, you go back to paper. about 3 volts. So I'm going to drop 3 volts here. That's going to leave me 7 volts it's got to drop across to R2. So if we do the calculation of R2, I have a resistor of 220 ohms. I still have the current. And that, if you do the calculation, it actually comes out to about 6.9 volts. So I'm real close to my 10 volt source. So Ohm's law in a series, the current, the electrons can only flow in one path. It can't flow anywhere else. They go through resistors. The resistors have to drop all the voltage that is in my source. Understanding the correlation of all 3 of those together is the foundation of Ohm's law.